We'd like to now invite Mike Loweth with Oxford Space Systems to the stage.
Hi, good morning. So my name is Michael Loweth, and I'm here from Oxford Space Systems to talk to you today. Firstly, thank you to NASA Ignite for letting us come out here and present here, and for the help in putting this presentation together. So, we make deployable antennas and structures, and why does that matter to you guys? Well, our technology enables a lot of different technology from space, and here we look at SAR imagery. Now, your optical imagery from a satellite needs sun to see. So if you're in cloud, if you're at night, you can't see what's happening on the ground. SAR imagery self-illuminates it. It sends a radar pulse through, so you can look through cloud, you can look day and night at what's happening on the ground. And that's really important for a number of commercial activities, and particularly for defense activities. So what we've done is we've taken a very capable antenna and worked out how to wrap that right down so we can fit on smaller satellites. And that really is an enabling capability that lets us look at multiple satellites, not just one or two. The same technology can also be used for communication, so giving you broadband around the world, which is something most of us are seeking whenever we're traveling. And to give you an idea of how effective our stowage is, just look at the OSS circle near me. I'll skip on otherwise. So that's going from a 2 foot or 60 centimetre diameter circle out to a 2.7 metre or 3 yard diameter antenna, which gives you great performance and starts to get you towards the SAR imagery that we were showing you earlier. So we're not the first to do this. Why are we doing this? It's because the current legacy solutions, they use traditional materials, they have long lead times, they're costly, they have a number of challenges. And we came along and realized that we could actually redesign this and revolutionize the performance. So we look at novel solutions, looking at origami engineering, looking at materials like this, where we take carbon fiber, play around with the chemistry, so that we can then deploy it, like that. And this is one example, but we then use this kind of material technology to develop through until we get to that wrap rib antenna. These solutions mean that we're lighter, more storage efficient, and this really enables a smaller satellite to punch way above its weight, and in doing so, allows for these large constellations of tens, hundreds, even thousands of satellites. And in doing this process, we've amassed a number of patents and extensive internal know-how. And this is all underpinned by our growing and diverse team. We're doubling in size every year, and we're now at 54, unless we've grown since I've been away. Selected highlights on the funding. So we started in 2013, we got funding early on, and our early successes that I'll tell you about, where we got technology into space in under 30 months from our beginning, really helped to give us those inflection points to get that equity in. Now, we have the highest private equity funding for any UK space hardware company. So we're really proud of how fast and how well we've grown. In doing this process, we've thankfully managed to amass a number of awards for both our material science, for our physics science, for our innovation, and for our entrepreneurship, as well as for the rate at which we grow. In this process, in this growth, we've had a number of collaborators, and you'll recognize the names, and I'm not going to go through all of them, but one of the things I want to bring out is that we have been awarded the largest first ever contract, the largest contract for first ever contract into the UK government. So that Ministry of Defence wanting to give us this money, such a large amount, is a real stamp of encouragement for us. So I've gone through briefly there, and now I want to actually show you some of our products, give you an idea of what we actually do. So we've got three key areas, as I started to allude to earlier. We've got our unfurlable antennas, we've got our structures, deployable structures, and then we've got deployable panels. And always our ethos, our target is to be lighter, less complex, and more storage efficient. And it's really trying to revolutionize what's there. Our first launch into space, you see on the far side, got us 2 world records. It was the longest retractable boom on a nano satellite. It was also the fastest time from concept to orbit and deployment in space. In under 13 months, we got this idea and put it into space. And that's not a normal space schedule. That's normally more like 5 or probably 10 years. Nearly straight after that, within a couple of years, we were launching or deploying this unit. And this was for an Airbus satellite called Remove Debris, where they wanted to look at a number of examples of how to get rid of space debris from orbit. So they said, we want that, get it up there. All we want to know is, once it's deployed, it's going to be stable to give us a good target to shoot with our harpoon. It was their riskiest mission, so it was the last one they did. So we had to wait in orbit for about 9 months before we actually deployed it, and complete success. Moving on to some of our other products, we've got our patch panel array. So this is a 2-axis steerable panel. That satellite is actually a 6U unit, so it's 10 centimeters by 20 centimeters by 30 centimeters. And on that panel, we've got KU band and S band patch arrays. And on the other side, we've got space to accommodate your solar array. So you can really maximize your performance to either your communications package or to your solar array on the back, depending on the needs of the mission at that time. So now we look at the tri-filer. So this is one I really like. So it's going to be our next launch, that helical on the far side, and that compresses down to just 5 centimeters, a couple of inches, to go into a half a U, so 5 centimeter by 10 unit. We talked to the customers to start with, and from the initial discussion to getting that qualified and ready to go into orbit was under 16 weeks. It will be launched in August, and that will mean from concept to launch in under 7 months. That's the new space pace that we are really trying to achieve here. And we've got more complex versions in the middle here. You can see an example where we actually drive that deployment out. And not only do we deploy in length, also in diameter, which is quite a brain ache if you want to try and do it yourself. I wouldn't advise it. And then these go up to much larger helicals, up to 10 meters in length, which is great for your small satellites rather than just your CubeSats. So now let's start on the unfurlable antennas. We're going to start from the big side, so outer ring or hoop antennas. Traditional antennas like this have a whole network of cabling that force a metal mesh into a parabolic shape to give you that reflective surface for telecommunications and SAR sometimes. What we realized was we could bury that technology into the outer ring, so it basically deploys by itself, and really simplify that solution, giving you a more reliable solution. And we've been so successful that we're looking to have our first launch next year with a US customer. Looking at that surface material, you saw it being folded and unfolded. Here you see a much more complex pattern where we fold it into a much smaller form. This is that pre-shaped membrane. So what we do here is we make this membrane on a mold so it knows the shape it wants to be. When we fold it up, we launch it into space, and we unfold it, it wants to resume that parabolic shape, which means you can get rid of all of that cabling that forces it into a parabolic shape and make it simpler, easier to make. And this is where we are trying to make sure that the products we design are designed for manufacturability, not just for making one-offs, where we can really focus our activities on these constellations. And as you say, result is a much simpler solution, and we think it will blow the competition away. Wrap rib antennas, these are smaller ones, what I showed you right at the beginning. Now, this is really groundbreaking for us because this is where the MOD invested that £1 million, which is the biggest first-time investment they've made in a company like us. It's also where the UK government has invested another £1 million for us to work with SSTL to actually get a simple version of this into orbit in just 2 years' time. That is a tight timescale, but we're going to do it. In doing this development, we've had to look at a metal mesh in this case because we need to wrap it up. And in doing so, we developed a UK metal mesh with a UK partner, and the performance we've seen back, this is ESA, European Space Agency results, on reflectivity. So a perfectly reflective surface would be that zero line right along the top where I can't reach. When we compare our technology to incumbent US and other European possible competition, we see that we are that blue line, and when we look at Ka band communication, for example, we have roughly half the losses of the incumbent solutions. So in every phase of the solution, we are trying to come at this again and come up with better solutions using modern methods and technologies, moving away from those traditional materials. Then we come down to a smaller unfurlable antenna now, bifold. So these unfold like an umbrella and then unfold again. And these two are 60 centimetre diameter, fit into a 2U volume, so 10 centimetres by 10 by 20, smaller than a loaf of bread. But if I look at this membrane here, I can show you exactly how that works, like that. And that's got great capability, because not only can we put this onto a small CubeSat, we can start to put this on other vehicles. We can put this onto your rovers to replace those patch arrays you've got there. We can give this to your explorers when they're testing units in the Arctic. We can put this into soldiers' packs to give them that high bandwidth communication to satellites. It's immensely flexible and operates up to Ka band again. So I've given you a whirlwind view. So I'll give you a quick conclusion. We have a number of different product lines, and in fact, the bifold solution isn't even on here because we just haven't had a chance to put that in there yet. When we look at the helical antennas, you can see we've got launches coming this year, and we think we're going to have a lot of those. So we're looking at something like 200 antennas. That's something like £5 million worth of business there. We're looking at deployable panels, which we need to develop and put through, but again, perfect for constellations. And it's so much what we're looking at, trying to target. And so there we're looking at in the order of 400. It's going to take us a bit longer to get those into orbit. But if we get some good opportunities from the likes of you guys or others, we'll accelerate it. And then deployable parabolics. So we look at these large hoop outer ring antennas. Not so many, 8, but they are the big ticket items. You're talking about $50 million worth of market there. And then below that, those rat rib antennas, which is something like 50 antennas, and that's going to be on the order of £15 million worth of business there if we can capture that all. How are we going to do that? Well, we've got a team of 54 really talented people, and to name 3 of them, our CEO, Mike, he's successfully exited from 2 technology businesses already. Juan, our CTO, he's an examiner for one of the top UK aerospace universities. Matt Rowe, he's worked in a number of different industries and had some massive project values in the order of $500 million. Really capable guys. But I wanted to finish on something a bit more exciting as well. This is one of our blue sky ideas where we've got a patented Origami sat. And the idea was, why deploy an antenna from your satellite? Why don't we just deploy the entire satellite? So we talked to some of our origami experts, and using this rigid panel origami, we worked out how we can deploy the entire satellite out to really maximize the surface area for our arrays. So this means we can really maximize those communication or SAR applications on the front, and this is a patented solution. Or on the back side, we have our solar arrays, to make sure we get the power. And you can see you've got thicker units in the middle where we can mount your computer and your AOCS. And this is something that's got a lot of interest both in the US and the UK. And we are already breadboarding and modeling how we're going to make this. And not only do we deploy it, we can also restow it for stealth or to avoid space debris. It gives us amazing flexibility. With that, I'll say thank you very much and ask for any questions.
Thank you, Mike. Questions from the judges?
Hi, Mike. Hey, thanks very much for that. That was pretty amazing. A couple of things I just wanted to figure out here. It doesn't sound like you're here to look for money. It sounds like you're here looking for clients, which I totally get and understand. I guess the one question I have on the technology side is, do you see that 3D manufacturing of certain types of these kind of space-based entity, well, I'm not looking for the right word, but 3D printing of this type of specific could impact your business model?
We want to use it. We've got our own rapid prototyping or 3D manufacturing capability in-house. And it's one of the things that we want to use to make sure our products here are more effective. You're right, in the future we may start looking at 3D printing in orbit. But at that point, if we're already using it on the ground, that just enables you to replace those antennas in orbit. So I don't see that as a challenge. I see that as an enabler. Does that answer your question? Thank you.
You said you made the longest boom from a CubeSat. Can you tell me how long it was?
I have to remember, it's something like 1.8 meters, so 2 yards, something like that, from memory.
How long could you make it?
We're looking at in the order of, I think, 10 meters. I have to work in metrics, I'm afraid. And if we're looking at our Attitude Max, where we sort of have a carbon fiber tubing around the outside telescopic tube, then we're looking at 15, 20 meters solutions. The biggest challenge for us there is making sure that we can make these 15, 20 meters in one long unit. And so the only limiter is getting more facilities that allow us to make larger units.
And so what's the expansion coefficient? Do you have a measure for that?
I don't off the top of my head. It's because we're based on carbon fiber, it's pretty good, but I can't give you a unit off the top of my head, I'm afraid.
Thank you.
Have you looked at the Canadarm? I know it's bulkier, but I think it covers a greater distance.
We've looked at that, but what we found was when you saw the picture where I say the 3 units we make, the outer ring, we actually use this boom technology with this concentric telescopic boom outside, which we could make up to, as I say, currently 15, 20 meters long. That is very strong and very light. It's class leading from the numbers we're getting. And because we're going to be launching it in a year's time, I think that's a sort of capability we think will surpass things like the Canadarm.
Yeah, I was going to say, I think you should expect a phone call from them anyway.
Give us a call, happily. Yeah, thank you.
Thank you.
Mike, I got one for you.
Yeah.
In regards to the constellations, any conversations yet with SpaceX or Blue Origin or OneWeb?
We've had a number of very interesting conversations with a number of companies looking at these opportunities. Because generally they tend to be under NDAs, I can't mention names here, especially on a live stream forum. But we have had a number of discussions, and we're always keen to have more. So please contact me.
So, and this is coming from someone who has a perspective only really in software and light hardware companies,
Yeah.
and nothing that's ever been in space or where a couple disasters could ruin your company, and you deal with that all the time. You said that you have doubled your headcount almost every year for several years, and you clearly have a culture that is perfectionist, awesome, shipping product, and I don't even know how you make something and then shoot it into space 7 months later. That's crazy. But how are you going to keep that as you move from 50 people to 100 to 200, and
Yeah.
when are you going to stop scaling?
You're right. I don't know when we're going to stop scaling, to be honest, but it's one of the challenges we have, finding the good quality people. We've been really fortunate in identifying and hiring amazing RF engineers, amazing material scientists, and this is the challenge we continue to have. And one of the best answers I can give you is by us coming to these events, by us getting NASA iTech Finalist Awards, it raises our profile and means that those universities, those young engineers that are really enthusiastic, that are annoyed with all of the paperwork they have to do in traditional space, can come to us and say, let's go make it happen, boys and girls. You know, that's where we are. And I think we're doing really well in attracting people from around the world, and we're keen to attract more because we have to.
Thank you.
Thank you.
So I'm impressed with the capabilities for this expandable, structure system you have. That's really cool. What I want to explore more is the last thing you showed. That is the cool thing. That's leading edge. That's what when I coach you to identify whole new form factors for these new architectures or this expandable, compact expandable structure. Because we've been using these tapes and different things like that, like you have that for a while for booms. But the idea of combining that with space systems and a whole new structure form for these space assets, I think is spot on, and that's where we're going to focus our attention this afternoon.
Yeah, thank you very much.
I'm just wondering, when it comes to, you mentioned use for the military, the soldier explorers and the like. There could be other domestic types of uses.
Absolutely.
What kind of price points are you imagining?
This is exactly why we don't have it on the roadmap, because the opportunity we've had to really identify that market and to see how we can engage with it and meet their specific needs is something that we're going through at the moment. So the more help and support we get from these sort of forums in terms of these are the guys that want to make that happen, this is some funding to help you get that market analysis, to get those field demonstrations. That's really one of the growth areas that we're looking at, and it's a very exciting area, to be fair. But you're right, we don't have the full answer to that yet. It's one of our future bits of excitement.
Very cool stuff. I really liked how you described it as origami engineering.
Yeah.
Just a question about your product lines. So it looks like you have several different product lines. Can you talk a little bit about why you chose to sort of branch out and have several product lines rather than focus on one or two?
Brilliant question. One of the things that, because we've got such a good team of creative engineers and scientists, we really try to encourage ourselves to look at new opportunities, new solutions. So what we'll often do is we'll breadboard a lot of these different ideas and say, hey, we've got this great idea, well, let's go rapid prototype it, see if it actually works. So it's not a lot of money put into the R&D, but just see, is it practical? And then when we start talking to our potential customers and they come to us with their problems, we say, well, geez, we got that central mask that we use on our rat rib that puts a secondary reflector out. We could use that for your optical telescope instead. How about that, guys? And so we've got this sort of whole card pack of potential solutions. And if that's the one that you need and there's money in us actually developing that on, we'll look to put that into our portfolio of products. People have been coming to us with a lot of challenges, and we want to keep that portfolio as small and focused as possible. But we also want to help you guys get into orbit. So it's that trade-off of trying to keep focused, and that's why we tend to focus on those 3 or 4 areas. But we've got this great wealth, and if you come along with a big market opportunity, we're not going to say no. Does that answer your question?
It does. Thank you.
Thank you.
Mike,
Yeah.
I had when you unfolded that on stage and when we saw some of the videos, I had this flashback to George Jetson, packing his car in his suitcase. And I was thinking, along the lines of what you're thinking about with new products. I mean, does it lend itself to, at some point, you know, you've got a box and you just go pop and you've got a drone ready to go. You just stick the motor on and off you go. Is that where it's going?
I think there's a lot of opportunities of where it can go. The challenge is working out where the markets are, because we are venture capital backed. We have a board we need to answer to, and any of these developments need to be financially focused as well. We want to have that company value and potentially exits as well. So I wouldn't say it's not where we're going to go. I would just say that at the moment we want to keep enough of a focus so that we don't end up with too broad a range of products. It's, you know, kid in a candy store. We could do 101 things. We've got to keep at least somewhat focused. But yeah, we haven't quite got to the suitcase car yet. I'll let you know when we do.
Then again, with no space experience, so I couldn't tell you if different countries have different standards or something like that. Are you planning to sell your material technologies to any nation or only specific ones?
We are trying to be an international company. So we've already got business where we're going to launch with an American customer. We've got business in the UK, in Europe, in Singapore. We are working around the world. There can sometimes be considerations on security and those sort of areas, but when we get to those points, we'll address them. We've got experience in-house to do so. So for us, it's basically trying to address those markets as proactively and new space schedules as possible.
Thank you.
Thanks. Any
Thank you,
more
Mike.
questions?
Thank you.
Thank you very much. Bye-bye.